Hello, everyone. Welcome to our presentation on Guide to Responsible Governance of GenAI in Organizations. Earlier this year, a diverse group of industry experts came together to pinpoint the most pressing concerns and gaps when it comes to governance of GenAI, and their insights sparked the guide that we'll eventually walk through today. A heartfelt thank you to all of the industry experts who shared their real-world challenges and lessons learned. We've distilled their perspectives into a white paper and then later transformed those findings into an open source interactive guide called ResAI. So in this session, you'll see key governance patterns that we've identified, our multi-level model for embedding controls, and then finally a demo of ResAI itself so you can take these best practices straight into your own projects. Everything we discussed today will be publicly available, no proprietary barriers, so you can adapt these resources directly. Let's get started. So here's our roadmap for the session. We'll start off, well, we already had our speaker introductions. Thank you, Mark. But we'll move on to the motivation and the why behind responsible governance of GenAI. Talk a little bit about the key governance challenges and barriers when it comes to real world hurdles that we see that when it comes to GenAI governance within organizations. A survey of the existing frameworks and gap analysis between them just to understand what's already out there and where it falls short. And then we'll dive into our multi-level governance model and its foundations and pillars, as well as the lifecycle approach that we're taking when it comes to governance. And then finally, we'll have our hands-on demo of the ResAI guide and wrap it up with some conclusions and key insights, as well as Q&A. So we had a lovely introduction, but on this slide, I would like to specifically highlight Himanshu Joshi, our senior project manager at Vector and MIT alum, whose strategic advice shaped both our white paper as well as our ResAI guide that we'll be going over. Now, let's take a step back and look at why we actually need an approach to governing generative AI. Companies are racing to adapt GenAI tools, whether it's for chatbots, code generation, or automated content creation, but many actually lack a clear framework for managing the unique risks that come along with them. Now, here we've outlined 4 key areas that illustrate the stakes. The first one being unmanaged ethical pitfalls. So generative models aren't just advanced autocomplete. They can hallucinate misinformation or reinforce harmful stereotypes if left unchecked. So governing GenAI means putting guardrails in place so that these systems generate outputs that we can actually trust. And then we have operational blind spots. It's all too easy for rogue AI instances, so what we call shadow models, to slip into production without oversight. A governance framework actually ensures that every model deployment goes through some sort of standardized checks. And then we have data privacy and compliance gaps. GenAI thrives on massive data sets, but that data often comes with strings attached. So consent requirements, retention limits, or lineage obligations. And good governance makes certain that we respect those rules right from the outset. And then we have ambiguous accountability. So finally, when an AI decision goes sideways, who really owns that mistake? Without a clear assignment of roles from data engineers to compliance officers, we often end up scrambling after the fact. Now, by recognizing these challenges up front, not as abstract worries, but as real business critical risks, we see the need for a practical, repeatable governance approach. Now, on this slide, we've distilled 4 of the biggest real-world barriers that organizations hit when they try to actually govern their generative AI efforts responsibly. The first one being opaque decisioning. So this first challenge is that most GenAI models are kind of black box. When a business user auditor asks, why did that model produce that output? There often isn't a clear answer. Without on-demand explanations or traceability, every investigation turns into a forensic exercise. Models just spit out the answers and you can't debug or rationalize them in real time. From a governance standpoint, this opacity kills auditability and impedes accountability. If you can't demonstrate how a decision was reached, regulators and internal stakeholders often lose confidence. And then we have rapid model evolution. Now, this second barrier is most likely to do with speed. Gen AI models are evolving constantly. Teams fine-tune live models on fresh data, deploy new versions weekly or even daily. Static governance policies or one-time checklists simply can't keep pace. Controls that were valid yesterday may be obsolete today. This mismatch really creates a gap, and new risks emerge faster than policies can actually be updated, leaving organizations exposed. And then the third risk, cross-functional friction. There's cultural friction between teams. So data scientists that want to experiment and optimize for accuracy or business KPIs, but then there's also compliance functions that demand structured audits, trails, and rigid documentation. Because there's no shared risk taxonomy or language, every conversation about governance almost becomes like a tug of war. Data scientists see red tape, compliance teams see gaps. That misalignment slows down project approvals, forces endless back and forth, as well as even derails promising use cases. And then lastly, we have tooling and integration gaps. Now, most organizations lack an integrated platform for GenAI governance. You end up cobbling together ad hoc scripts for bias checks or have separate dashboards for drift monitoring and disconnected spreadsheets for consent logging. Those point solutions create new blind spots, handoff errors, and silos, so no single view of your entire governance posture as a whole. Now, in practice, governance becomes a manual, error-prone headache, not a streamlined part of an ML lifecycle. Before we dive into the existing landscape of frameworks, let's just agree on a yardstick that we can use to actually evaluate the frameworks or what exists out there. The first one being something that is risk-based, right? We must tailor the controls to real failure modes of each GenAI use case. A small proof of concept chatbot doesn't need the same level of oversight as a large-scale customer-facing deployment. Now, by mapping controls to both likelihood and impact, we often avoid over-engineering while still covering truly high-risk scenarios. And then we need something that is continuous and adaptive. So unlike traditional software, GenAI models do evolve daily, as I've mentioned a few times, through some things like fine-tuning new data feeds or model API upgrades and so on. Therefore, static, once-and-done compliance checklists collapse under this pace of change. Instead, we need something that encourages governance as a code, where policies are versioned, tested, and auto-applied every time the model or pipeline updates. And then we have something called cross-functional. So effective governance can't live in silo. We need legal, compliance, security, data science, DevOps, all of those people speaking the same language. So early and ongoing collaboration usually helps prevent surprises, and it turns governance from a gate into a shared shield. And then we need something that covers the life cycle as a whole. Governance can't be an afterthought at deployment. It has to touch every phase from project scoping and data ingestion through development, deployment, monitoring, and ultimately model retirement. This end-to-end approach ensures that no stage slips through the gaps. And then lastly, we need something that is actionable and modular. High-level principles are valuable, but teams need concrete artifacts like checklists, playbooks, code snippets, and policy templates. By providing plug-and-play modules, we empower practitioners to actually adapt these controls immediately rather than reinventing the wheel later on. So now that we've covered the core principles of effective GenAI governance, let's take a look at the current landscape of high-level frameworks and where they kind of fall short in practice. On the top, you can see some of the most widely adapted standards and guides, documents from NIST, AI risk management frameworks, to ISO frameworks, Singapore's Model AI governance framework, as well as best practices and guides from the Responsible AI Institute, as well as MIT's AI Risk Repository and Alan Turning's Institute's safety principles. Each of these works do offer valuable building blocks like risk taxonomies, ethical principles, control matrices, and so on. But when we really overlaid them against real world needs of generative AI applications, three opportunities emerged. The first one being governance, flexibility, and scalability. So these existing frameworks tend to assume either a fully mature enterprise program or a bare bones checklist. They don't give you a straightforward way to dial governance up or down based off of your organization's size, sector, or AI maturity. And then the second one being stakeholder collaboration. Many of these documents leave accountability ambiguous. Who owns a risk assessment? Who signs off on remediation? And how cross-cultural teams coordinate. So that friction really slows down the approval cycles, creates hidden blind spots as well. And then lastly, we have proactive risk management. So finally, most frameworks are geared towards one-time assessments or annual audits. They don't explicitly integrate continuous monitoring or automated policy updates that keep pace with rapid model iterations and evolving data. These gaps don't just really highlight what's missing, but they directly inform the design of our multi-level governance model and the modular workflows in our guide. So with those gaps in mind, we've co-designed a governance model that operates on 4 interlocking layers, each representing a team and scope of work and all feeding back into one another. I'll start off with the strategic layer, which is more about risk mapping. At the top, C-suite risk committees set the direction. So they pick the right taxonomies and frameworks, for example, the MIT risk repository or sector-specific casual maps, and then prioritize the highest impact risks for your business and regulatory landscape. This gives everyone clear guardrails, definitions, as well as risk backlogs to actually work from. And then we have our tactical layer, which is more about continuous monitoring. So next, your DevOps, security, and compliance teams implement real-time controls. Think automated drift detections or anomaly alerts and policy gates embedded into your CI/CD pipelines. These tools constantly feed back performance and compliance telemetry to the strategic team so risk maps stay up to date. And then we have our operational layer, which is more about the mitigation strategies. Now, down in the trenches, data scientists and engineers translate these prioritized risks into code and processes. They follow playbooks, risk matrices, privacy impact templates, bias testing scripts, and so on that trigger automatically when certain thresholds are hit. This layer sort of ensures that the controls are actionable and repeatable, not just theoretical. And then we have our organizational layer, which is all about training and upskilling. Finally, we have HR, L&D, and project managers, which embed governance literacy across the firm. Role-based training, self-service toolkits, regular drills, just to make sure that everyone from the VP of data to the ML intern knows their responsibility and has the skills to execute it. Now, notice the arrows. We have insights, incidents, which flow down from the strategy into operations and back up as data and learnings. That bi-directional loop is what makes this a living, adaptive model rather than a static checklist. Bottom line, by aligning each layer from high-level risk mapping all the way to individual developer checklists, you get governance that's integrated, scalable, and continuously improving. Now that we've seen our multi-level governance model in action, let's actually dig into the core foundations and pillars that support every responsible GenAI initiative. So at the base of the temple, we have our foundation layers, which are data strategy and governance. Now, this is our bedrock, defining where data comes from, how it's classified, secured, and shared. And then we have ethical and responsible AI practices. So embedding high-level principles, fairness, transparency, accountability into every policy and process. And then we have best management and engineering practices. So lean DevOps style pipelines, code reviews, versioning, CI/CD, all adapted for AI. And then we have AI and data literacy and education. So ensuring that everyone from business leaders to data engineers speaks the same language around AI risk and benefit. And then we have our use case evaluation and sandbox teams sitting just above the foundation. These cross-functional squads prototype new GenAI applications in isolated environments. They validate feasibility, identify risks early, and refine controls before anything actually goes live or is deployed. And then we have the pillars, so the vertical columns. Each pillar represents a key capability area that must be operationalized. I'll start off with AI risk management. So formal risk assessments, registering scores, and triaging model risks. And then we have security and privacy, which is about data encryption, access controls, and consent logging mechanisms. Compliance and audit, which is documented processes, and audit trails for regulators and internal stakeholders. And then we have control and reporting, so dashboards and KPIs that surface drift, bias, performance anomalies, and all of those sorts of things. We have operational efficiency and training, so role-based upskilling, so teams know not just what to do, but how to actually do it. And then evaluation toolkits, so fairness tests, robustness checks, TEVV workflows, explainability libraries, and so on. And then trust, safety, and alignment, so guardrails against harmful outputs, prompt filters, content moderation workflows, continuous monitoring and improvement. This is very important as well, a feedback loop that actually feeds insights back to strategy. And then accountability, so clear RACI definitions, so responsibilities and sign-offs never actually fall through the cracks. And then at the very roof of our temple, we have strategic alignment and oversight. This is all about AI principles, policies, and adoption council. And at the very top, steering committees and executive sponsors ensure every pillar and each project actually stays aligned with organizational values and risk appetite. Now, having outlined building blocks of our governance temple, let's look at how you can operationalize these ideas step by step throughout your GenAI lifecycle. We've distilled 6 practical checkpoints that align perfectly with any project workflow, starting off with ideation and planning. Now, the key task here is to establish ethical guardrails, data rules, clear objectives before writing a single line of code. By defining governance checkpoints or criteria upfront, you actually align stakeholders on acceptable use cases and reduce the rework later on. And then we move on to data collection and preparation. This is all about verifying data lineage, ensuring that representative samplings exist and confirm consent permissions before actually training. Now, it matters because early data checks safeguard against privacy violations and entrenched bias into your models. And then we move on to the actual model development and testing phase. The key task here is to run rigorous TVV workflows, testing, evaluation, verification, and validation, including fairness, robustness, and security checks. Now, controlled experiments catch defects and unintended behaviors before they actually reach production, which is why this is pretty crucial. And then we move on to the actual model deployment phase. Now, the key task here is to enforce version gates, apply access policies, and require formal approvals before going live. Matters because deployment controls preserve audit trails, ensure rollback paths, and limit unauthorized use. And then we have post-deployment monitoring. So continuously tracking model drifts, demographic biases, policy violations via real-time dashboards. Now, ongoing surveillance actually lets you detect emerging risks and adapt controls as inputs or context shifts. And then lastly, we have model retirement, which is all about offboarding through secure archiving logs, safe data purges, and generation of audit-ready reports. A formal offboarding process actually closes the loop, preventing orphaned models and preserving regulatory compliance. So embedding these 6 checkpoints into your existing ML pipelines means governance becomes an integral part of your process, not just an afterthought. And then now I'll turn it over to my colleague Lucas here to go over our ResAI guide.
So now we'll switch gears a bit. We're going to walk you through a tool that we developed to help you understand and apply the governance principles we've talked about today. So res-ai.ca is a public website that you can visit now to learn about AI governance in a hands-on and interactive way. I will walk you through some of the features of the site now, but also please note that this artifact is still in active development and is subject to change. So to start, when you first visit the website, you will see a list of panel items which you can expand and collapse, each of which detail a specific part of the guide. At the top, you also see a link to the publication and a button to get in touch with us. As you can see in the How to Use This Guide panel, the main way we anticipate users to interact with this artifact is by looking for specific section headings which are relevant to their problem, reading through those sections, chatting with our AI buddy to get context to our help, and then exporting action plans. By clicking on the circle on the bottom right, you can see what we're calling our AI buddy. This is an LLM assistant that uses both our paper on AI governance and other high-profile AI governance frameworks to provide specific and nuanced feedback on your AI projects. It has support for both ChatGPT and Gemini Foundation models to provide extra coverage, but defaults to using Gemini. Clicking on the top right arrow allows you to view the AI Buddy disclaimer and reset your conversation history. But please note that currently this tool does not support recovery of past conversations. We recommend that users start by viewing the tutorial so that they know how to use the AI Buddy effectively. Click the Start Tutorial button to preview what a sample conversation might look like, and you can type End at any point to end the tutorial with the buddy. You can also click on the top left-hand button to expand the window to full screen. As you can see by the tutorial, the AI Buddy is asking the user for additional information that helps to map the project to specific risk items in the various AI governance frameworks. The user can answer as many or little of these questions as they like, and the buddy has a general sense of how conversation should flow, guiding the user to extract relevant information and identify areas of improvement and risks in the project. There are three primary types of conversations the buddy can support, which are questions about the paper itself, recommendations for complying with AI governance, and identifying risks for AI-based projects. So let's test out the first type of conversation by typing the following. So we'll say, what are some of the key governance challenges the paper talks about? After the user sends a message, the first thing the buddy does is categorize the message into one of three types of conversations I mentioned earlier. And a question like this will likely be categorized as a question about the paper. But the categorization is also done by a separate task-specific LLM, which can still hallucinate just like any other LLM. Reading the response, we can see that it extracted the information from the paper and ended the message by asking the user a follow-up question to continue the conversation. You'll also notice an option to indicate that you're not satisfied with the answer, and when selected, it will ask if you want to upload your own files to get more personalized results. So now, let's see the risk identification path, because we anticipate this would be one of the primary use cases for this artifact. So we'll enter the following. I am working on an AI tool to help tutor students in a classroom setting. The target audience is students from 7 to 11 years old, and what are some risks I should watch out for? Here, the model has identified that we're looking for risk identification help, and so it is asking us if we would like to use any specific frameworks in addition to our paper. And this is used to help identify those framework-specific risks. So for this demo, we only want to use MIT's risk repository. And when you use this tool yourself, it may take some time for a response to generate because the model is considering a very large amount of context in each response. And this is to provide the user with the best and most relevant insights for their project. So reading through, you will see that the risks identified are very relevant to the project mentioned, and the model will often cite specifically where it's pulling the risk information from. Notice at the end of the message, it asks the user if they would like to draft an action plan from this conversation. We can do that by hitting the export button on the bottom left. Also note that this will usually take quite a while too, because it is not just exporting a transcript of the conversation, but rather it's using another LLM to first analyze the conversation, process, and format an action plan following common action plan templates. Opening up the action plan, you can see there are usually fairly short documents that are to the point. At the end of each action plan, there are links to additional frameworks that you can explore for further help. Some of these other frameworks are not public, and so we cannot use them to provide context to the AI Buddy, which is why we still highly recommend reading through them yourself. The last thing I wanted to mention about the Res AI site is that within some of these panels, you'll find forms that can help tie in what you learned from the relevant section of the guide. So take the guide objectives panel. This panel covers some of the core principles of responsible GenAI governance. And at the end, you can input information about your project to see how well it aligns with those principles. Filling out this form and clicking the Submit button will open up the AI Buddy automatically, and it will first paraphrase your response to the form and then provide helpful information relevant to what you entered. So as we wrap up, here are some of the key takeaways to carry forward. So you should treat ethics, risk assessment, and accountability not as one-off checkboxes, but as embedded practices at every stage of your GenAI lifecycle. You should move quickly with prototypes, but pair each sprint with proportionate controls so that you stay agile without sacrificing transparency or safety. You should leverage a multi-level model. So align your leadership on high-level risk mapping, equip your technical teams with mitigation pathways, integrate monitoring tools for live drift detection, and invest in organizational training to sustain governance maturity. Consider using hands-on tools like risk mapping templates, checklists, and our ResAI site to support the AI governance decisions in your projects. You can leverage the ResAI chatbot for on-demand and context-aware guidance as your processes evolve. You should foster cross-functional collaboration on your projects. Successful governance lives at the intersection of data science, DevOps, legal, and business stakeholders. So create shared documentation and clear role definitions to keep everyone rowing in the same direction. Continuously measure performance, fairness, and privacy compliance, and be ready to update your controls as regulations evolve and new threats emerge. Responsible GenAI governance isn't a destination. It's an ongoing journey. By embedding these practices into your standard workflows, you'll empower your teams to innovate confidently, manage risk effectively, and build AI systems that stakeholders can trust. All right, thank you for listening to our presentation, and we are now happy to answer any questions. And if you have any questions after the Q&A session, please feel free to reach out to us by clicking the Get in Touch button on the ResAI site.
All right, Lucas, Dhari, thank you so much for that wonderful presentation. We do have a few minutes here, for about 2 minutes, to answer some questions. And the first one from Carlos D says, corporate governance is usually slow-moving and can't deal with frequent changes and high-velocity demands. Does it make sense to have different levels or tiers of governance, and within that, some technical governance for dealing with high-velocity events?
I can answer that. I think for sure, absolutely. I think it's almost the best approach to layer your governance. You can almost have it in 3 different approaches, right? You can have a strategic approach, which is more so dealing with the slow velocity events, where you have the executives and compliance set high-level risk appetites on policies on quarterly or annual cadences. You can almost have a operational layer, right, which is more about that medium velocity, where program leads and auditors turn these policies into repeatable playbooks and approvals, updating these project milestones based off of the governance policies or compliances that come out. And then you can also have a technical layer, which is more so fast velocity, where MLOps are embedding some real-time checklists or drift monitoring or CI/CD policy gates and access controls right into those model changes every time they're being updated. So this way you can get some agility to catch the issues at every instance, while still maintaining some sort of oversight and consistency at the higher levels as well.
Thank you. The second question, please share recording. Yes, recordings and presentations will be shared after the event is concluded by the TMLS organization. So the third question, for regulated organizations, what are some key things to consider in terms of security when establishing an AI policy or framework?
Good question. I think when you're operating under regulatory constraints, security almost has to be baked into every layer of your AI lifecycle, right? So the first thing first is protect your data, encrypt everything, make sure that everything is anonymized if there are sensitive fields. Before you're actually training a model, keep PII or PHI within approved geographic or network boundaries. And then you have enforcing a strong identity and access controls. I think use least privileged roles require multi-factor authentication for any AI admin console and regulatory audits who can view, modify, or deploy models and data pipelines. You can also secure your development and deployment pipelines by integrating DevOps scans into every CI/CD stage, or vulnerability checks and dependency analysis into each of your stages to actually version your artifacts for both code and your models. So treat your training and serving environments as immutable or infrastructures. I think that would be the great way to put it. And then I guess one other thing that I would mention is that make sure you're aligning everything to your regulatory obligations. So crosswalk your AI specific controls to standards like HIPAA or GDPR or PCI DSS. Keep audit ready documents of these policies like risk assessments and remediation actions, and automate continuous compliance checks to sort of build that into each of your life cycle stages when you're actually deploying an AI model.
Okay, those are great answers. If I can also add to that, there's the Cyber Resiliency Act coming in the EU, and there's also the Cyber Entity Act in Canada, and I think the US is also working on legislation. And one more thing, there's the Artificial Intelligence Governance Professional Certification. I know somebody who did that one, and I think that's also a very good cert to have. The last question, I know the other talks have just started, but for those who are still on, the last question is, do you have any case studies to share of government, wait, did I miss one? No, let's see here. Junwei Huang asks, for GenAI governance initiatives in regulated environment, the presentation seemed to recommend a top-down process. From your past experience, what are the challenges to get the buy-in at the executive leadership level?
That's always, I think the buy-in is always a little difficult because there's a few reoccurring hurdles that come across. I think the first one being there's always competing priorities and ROI pressure. I think that's a huge one. You know, executives are constantly juggling their revenue targets or market expansion and so on and so forth. So governance can almost feel like a cost center unless you really tie it directly back to your business value, like avoiding a potential regulatory fine or preserving brand trust. I think that's a great way to kind of get across that hurdle. But then there's also things like, I guess, fear of slowing down innovation. I think that's also one of the things that come in at the top buy-in, because you know, high level risks like bias, hallucinations, or compliance breaches often sound theoretical, and leaders kind of need concrete examples in terms of here's how a single hallucinated contract clause could cost us millions in legal fees, or here's how a data leak could erode customer confidence overnight, in order to actually understand that, you know, the fear of slowing down innovation can actually provide you with great value in the long run.
Okay, and the last anonymous question, do you have any case studies to share of governance or lack thereof gone wrong?
That's a good thing to look into. Unfortunately, no, we don't have any case studies to share. But that, I think that would be a very interesting thing to actually do a case study on.